All right, welcome to chapter 8 on access control. As always, I'm going to share my slide to make this presentation a little smoother. All right, so my contact information, my bio, copyright. So in chapter 8 for access control, you hopefully will learn about identify and contrast popular access control modules, use account-based security to control resource access. There's two sub-modules in here, A and B. In module A, we're going to look at access control principles such as looking at Linux as compared to Windows NTFS. And then we describe MAC, ABAC, and other control access concept. On this slide, you need to know this for the exam. These are the general access control modules. The main one, DAC, discretionary, means if I own it, I can decide who can have access to it. The mandatory is based on security clearance, like top secret, confidential, secret clearance, more in the military environment. And then rule-based access, you're going to create rules, like access control rules. Of course, rule-based, if you're an administrator or secretary, this is self-explanatory. The ABAC is one that sometimes confuses people based on the attributes of the resources and the users. Then you can decide how they're going to, but let's explain them in depth here. This is the DAC. That's the one you're most familiar with. Do I have a file? I'm going to allow you access to it. The owner sets the permission. If you work on Linux, you need to know this, the read, write, and execute, both for the owner, the group, for the file. NTFS for Windows system, especially the new 64-bit operating system, you will see this. You have an SID attached to it, which is security identifier. And of course, you have metadata attached to the object and then the subject. The mandatory access control, this is called the Bell-LaPadula model. Again, it's centrally managed by administrators. You have issues about, again, I said secret, top secret, confidential, unclassified. Can you write, can you read to the file? This one, what you need to remember is it is mandatory. If a file has secret clearance, if you have secret stamped on it, you must have secret clearance to access that file. And then, of course, the role-based one is a form of mandatory access control, but in this case, obviously, it's also centrally administered. And just like the discretionary, you can give access to individual resources. And then this is the rule-based one. It could be static or they could be dynamic rules. These ones are pretty much easy to remember if you know what you're trying to do. So just keep that in mind. The attribute, this is sometimes called the next generation one, because it's a little more flexible as opposed to the other ones that seem a little more rigid. So every time you request an access, the system evaluates it according to a set of policies defined by an administrator. This is conditional access, like in Microsoft Azure Active Directory. See how this works? 1, 2, 3, 4 process. Number one is the user requesting it. He checks it and then decide whether to allow it based on maybe MFA or to block it. So how do we basically control access? You have all those, besides what we looked at before in chapter 7, we looked at authentication, but here for time and location-based access control, because sometimes people add this as part of the authentication methodology. Geolocation, using an IP address to determine your physical location, like the radio information, that's a geolocation. It's a general term for the technology. And then geofencing, we use GPS, RFID, radio frequency ID, or Wi-Fi data to identify the location of that mobile device and compare it to some kind of virtual fence that we created. And then geotagging, this is a feature of an application that allows location data to be embedded, like in a photo. You hear the word exit data, message online post, or any other kind of file or communication. This is very good for intelligence gathering. So know these three definitions, the distinction of the three of them. That seems like a good testable material, right? All right, so when we're talking about if a device fails, what do we do about this? This is more related to hardware. So when systems fail, you want to ensure that they can fail in a predictable way. It says when you want to use, it doesn't when it fails, it does the least amount of damage to your system. So predictable obviously means I can anticipate it, right? For like an electronic lock, know these two terms. You're going to see the word fail open and fail closed. Like in a bank vault, you definitely want it to stay closed when it loses power. But if you've got like a, say, building and the emergency lock fails, you want it to fail open so that we don't get trapped in the event of a fire, right? So it's a very short sub-module. But look at this question. Secure access control models are based on which assumption? Choose the best response. So this is tricky, but look at the word implicit deny. It means that if I don't give you access, you are denied, right? As opposed to explicit deny. So if you don't have the access listed, it's assumed that you're going to be denied. That's based on which assumption. That's secure access control. Don't give it to you, then you're denied. What access control module was popularized by the military? Military or government. That would be mandatory. That's a key thing to remember. What access control module is used by network hardware such as routers? Choose the best response. So routers they use rules to determine who's going to get into the network and who's not going to be allowed into the network. What group permission will a Linux file have if its permission is displayed as dash rwx dash rw dash dash? This is kind of tricky. If you know Linux system, remember stuff like chmods, but that's a little beyond the scope of this class. But what does this mean to you? See, the reason why it's A is because I have read write. That's for the individual, and then the groups is XRW, right? So the first one can read, write, execute. The next one can only read and write. That's why A is right. But you want to implement an access control module that lets you easily assign users to a combination of multiple rules and also restrict access to some actions based on the time of day and physical location of the user. Which module is the best fit? Choose the best response. So because I'm talking about attributes, will be the ABAC module. So in the module B, how do we manage account management? How do we manage each individual account or systems account? So here's you to describe the identity lifecycle components of the secure identity system, manage users in Active Directory, and of course, secure user account. So this is the life cycle for identity, your own ID, who you are, right? You have obviously, you've got, it's cyclical, or somebody might say iterative, but they have provisioned it for you. First of all, it has to be approved. Let's start with first. Approve what am I going to give you? Like your new employee, approve you to get an identity on the system. We provision it to you. The network administrator, system administrator gives it to you. You maintain it. Of course, if you leave in the organization or get fired or quit, we're going to deprovision it. So that's the full cycle on that. And each of them is very important, obviously for security reasons. So these are account types. Guest accounts are basically used to be stuff you saw before, like on Windows 7. They basically are kind of like by default nowadays, you don't use them, but you can see how it might be good if I have like a kiosk in my office or to log in, or in the hospital. You can see how you want to use a guest account. You want to avoid shared or generic account. Of course, a normal account is a user account, and then you can have service account for maybe database management system, but these are pretty much self-explanatory. But how do you prove identity? So identity proofing, you study KBA, like pre-arranged questions, like security questions. You have more sophisticated ones that can do that, or out of bound, meaning not in your system, require that full verification in addition to maybe online. That's all this is talking about. How do we prove your identity? How do you prove the identity, right, of the person that's trying to get into your network? The components for identity systems could be possession-based credentials like certificate, security attributes. You have identity providers, maybe tokens. That's all this is really talking here. But just understand that certain things that make up an identity system in a network. Right? So many times your username and password, which we would use the term credentials, how do we manage it on a network or in a system? So you have different options, Windows Credential Manager. Now you have even Windows Hello, keychains that store passwords. You can even use third-party management systems, right? Authenticator apps, enterprise and cloud credential management, even hardware security module, carry them with you. Key management system. These are just different ways to manage your credentials. And you will decide which one to implement in your network based on your needs. So how do I review access privileges? Or what should we do in our network? So the first thing you need to remember is what we covered, I think, in week number 1, about the doctrine of least privileges. Only give you what you need to do your job. And of course, privileged accounts, you receive extra scrutiny. I need to check them and periodically review permissions and contrast them with the person, the user says the subject's regular duty to avoid what called like privilege creep. You had one position, you get a new position, and then the privileges you had from the previous position gets into the new one. So just be careful, right? And always review your accounts to look for signs of intrusion or funny behavior. Be proactive. Right. Well, the privilege access management or PAM, it goes beyond simple account management, right? The whole idea is apply additional monitoring and auditing and enforce a request approval mechanism for whoever are going to use the privilege account. In Windows Active Directory, it's good to know how this works because most of us are going to be dealing with Active Directory, right? So these are how users and computers are monitored in the system. You provision it, you deprovision it, you manage it, and you audit it to see what they're doing. For groups, you have to hear the word about group scope. So if you're in a domain, local group, I assign you permissions on the local domain or global groups. And how do I differentiate between global groups and universal groups? That's all it's talking about. So the whole idea is to, if you give a single user a group permission, and if you give a single user or group permissions from multiple domains, it's a good way to manage your system. Right? So figure out which one is nestled inside. So you add the the global group to a domain, local group with necessary permissions. Let me explain that again. If I have a domain local groups, right? I want to assign permissions on the resources on that local domain. Right? So, but if I have global groups, I use them to organize users that share similar permissions. I have to talk about, figure out how you're going to, in other words, it's always better to assign permissions to group and then put people in that group and then remove people from that group. This would be an example of group policy management editor. This is a Windows system in here. You see how these guys can have security settings, besides account policies, local policies, event logs. That's how you can manage it centrally. Managing GPUs, where multiple GPUs applies, Windows processes them in the following order. Please remember this. So each subsequent GPUs overrides the one before. So the local GPU that's set on your current computer, now you have your site GPU, domain GPU, organizational and child organizational. So as you go down, that's the order that Windows processes them. This might be more in a complex enterprise environment. Password policies, there's a lab in there about enforcing policies like the length, the complexity, the history, password reuse. You want to balance usability with security. So always a tough thing for administrators. How do you manage user accounts? You need to define a user policy, have the restrictions, and what's the best practice. Enforce the policies with technological controls. So the number 1 is talking about administrative controls, right? You need to use technology to enforce it, or logical controls. And obviously always review the security and the logs to make sure that you are doing what you're supposed to be doing. Provision of the account just means giving an account, right? Starting the account. Always choose the usernames properly, have some standard naming convention. Many organizations, you have your first name and your last name. You know what you're doing, right? If you're going to give multiple accounts to a single user, just make sure that each account has a separate password. Otherwise, somebody gaining access to one gains access to all. And you should always assign administrators 2 accounts, one for their regular job as a standard, and then one for their administrative duties that has more privileges. Securing account access the whole idea is to allow users to choose their own password. If you're an administrator, don't ask them to tell you. That way you protect yourself. Besides minimum length, enforce the complexity requirement, mixture of uppercase, lowercase, numbers, special characters. You should have in your system a way to test the password against a dictionary of weak or compromised passwords and then deny weak options. So the NIST also recommends passwords should be changed when there's a reason to believe that the account has been compromised, not on a schedule basis, where you see many companies don't do that. They give you 30 days, 60 days, 90 days, but you do what's right for your organization, right? So users are most likely to use long, strong passwords when they don't have to remember them individually for each account. So the best way to do that is to use credential management software. And of course, always configure a lockout policy that will block access to the account after successive failed login. This is to avoid a brute force attack, right? But this is a good exam question. The most secure lockout require administrators override to unlock it. And some people decide to use a time-based, which means maybe after 5 minutes, you can get back into your account. That saves the administrator a lot of work, right? All right, a quick review. Which of the following is least likely to be part of PAM? Choose the best answer. Credential vaults with MFA. Restricting all administrators' actions to a single super user account. This is bad. That's why D is least likely, right? In Active Directory, where is the best place to assign permissions? Always a domain local group is the best way to assign the permission. During a discussion of user account policy, someone suggests lowering the account lockout threshold on Windows domain. What will be the net effect of this change? Think about it. This is kind of tricky, multiple question. Choose the best response. Is it less secure, less trouble for users? Or is it going to be more secure and more trouble for users? So let's dissect the answer. So account lockout threshold, which means maybe instead of saying 4, I'm going to use 2 or 1. But 1 is horrible. So let's say we use 3 instead of say 6. In other words, you try 3 times, then I lock you out, right? So that's more secure. But that also means it's going to be more trouble for users. That's why you always have to be balancing what you're trying to do. If a policy requires regular password changes, why would you set a minimum password age? Choose the best answer, right? To keep users from bypassing history requirement. Otherwise, it's just going to be reusing the same password or change. That's just the best answer here, right? It's not to keep users from choosing simple password. It's not to prevent attackers from easily cracking the password. It's like making it a moving target to keep users from bypassing history requirements. All right, it may have gone through this really fast, but access, because we've touched on this before, access control, describe the modules. You need to know DAC and MAC at the very least, discretionary or mandatory, military or owners. How do you set and interpret file access, manage the identity through the lifecycle, know those 4 life cycles for identity, and about policy. All right, so this is chapter 8. It kind of like ties into chapter 7 and some of the previous concepts that we looked at before. So I'll do chapter 9 and maybe 10 next week. But again, feel free to reach out with any questions, and I hope you're enjoying this video. I tried in the last video to make it 28 minutes. This one, I think I tried to make it under 20 minutes, but I'll check. So happy studying. Enjoy yourself and good luck on the exam, and good luck if you are my students at the university.